everybody. In this video we're going to talk about graphing exponential functions. So on your note sheet I've begun with a pretty simple example, and I'm going to start graphing this by making a table. So I'm going to choose some values that I will plug in for x and see what I get for y. So I don't know, maybe we could start with an easy number like 0, and to figure out what y is I would have to do 2 times 3 to the 0 power. So you have to remember your order of operations, or PEMDAS for short, right? So we're going to start with the parentheses. Well, 3 is inside the parentheses, there's nothing you can do. The next thing would be the exponent. So I'm going to have to do 3 to the 0 power before I do the multiplication with the 2. So 3 to the 0 power is 1. In fact, anything to the 0 power is 1. So this becomes 2 times 1, which is 2. And we could put that on our graph. So we have a point at 0, 2. Let's try substituting 1 in for x. So that would be 2 times 3 to the 1. Again, exponents first, so that would get us 2 times 3, which is 6. So I'll put another point at 1, 6. And I could try plugging in more values, but I think we're going to realize that it's going to get bigger than 6. Let's try some negative values. How about we try negative 1? So we'll be doing 2 times 3 to the negative 1. Alright, so here's what you have to remember about negative exponents. They really become positive exponents if you take the reciprocal of that number. So that becomes a 1/3 to the first power. So now I have 2 times 1/3, which is really 2/3. So there's a point at negative 1 and 2/3, so about there. And if you remember from class, we did some experiments with the M&Ms, right? We saw these graphs that grew exponentially, or they decayed exponentially, and they actually had this new feature, and you're going to see it right here as I draw it, called an asymptote. That's kind of a weird word, I know. I'm going to draw it in right now, make it a little thicker so you can see it. And it's like an invisible part of the graph. I'm trying to make it a dotted line so that you can see something. But what that represents is the value that this graph is getting very close to. So this is a horizontal, right? It's a horizontal line, a horizontal asymptote. Check out the spelling here. At y equals 0. That's where the line is. And the reason that that happens is because if you keep going in your table with negative values, watch this. If I plug in negative 2 for x, I get 2 times 1/3 squared, which is 2 times 1/9. So we get 2/9 here. And you'll see that that just keeps getting smaller and smaller and smaller, and it's going to approach 0. Okay, so when you have an asymptote, that graph is approaching that asymptote. So again, we started with a pretty simple function. In the next two examples, we're going to start with a simple function and then move them around. So this one might not look simple, but I just want to kind of break it apart into some pieces first. And notice that we have a +1 at the end of the equation. And I hope you remember that that moves the graph up 1. So it might be easier to make a table for the function. Let's see, if I plug in some x values and I just use what I'd call a parent function, if I just use the 8 to the 1/2 x. If you want to make a table for that and then move the points up 1, that's fine. Or you could just plug into the function in the first place. I will tell you that I think 2 points is enough as long as you can see the shape of the graph and you have the horizontal asymptote. So I'm going to start by plugging in 0 and 1. Here we go. So we get 8 times 1/2 to the 0 power. Remember, something to the 0 power is really 1, so this gets us 8 times 1, which is 8. So 0, 8. I'm not going to put the point on the graph, right, because we're going to move those points up 1. Let me plug in 1, see what I get. So I get 8 times 1/2, which is 4. All right. Now, if you wanted to, let me get rid of this work for a second. You could think of this as making a new table. If we move something up 1, that really just adds 1 to our y values. Right? So this is the moving up 1. So now our points are at 0, 9, and 1, 5. And I could have done that by looking on the graph as well. So I'm going to put my points at 0, 9, and 1, 5. Now the original asymptote, that dotted line that I drew in, was at y equals 0. But it got moved up 1. So that means that our horizontal asymptote is at y equals 1. Let me label that. That's y equals 1. I notice that this graph is actually decreasing, which makes sense because the value right here, I'm going to call it the b value, is a 1/2, right? So if you multiply something by 1/2 and you continue to do that, it's going to get smaller. So the graph is going to decrease. Let's try one more example. Okay, so now I see a graph, an equation that has 2 types of movements. We have the x plus 3 and we have the minus 4. So our x plus 3 is going to move this left 3, and the minus 4 is going to move it down 4. Again, if you want to make a table for this function, feel free to. I like to make tables for simpler functions and then move them. So I'm just going to start with a 2 to the x. That's a nice and simple way to make a table. So let's see, in my table I'm going to try 0 and 1. If I plug in 0, I get 2 to the 0, which is 1. If I plug in 1, 2 to the 1 is 2. Okay, so now if I graph these points, I'm just going to use my like laser pointer here to show you around. There we go. 0, 1. I'm going to move it left 3, 1, 2, 3, and down 4. 1, 2, 3, 4. I'm going to put a point right there at negative 3, negative 3. Some of you in class like moving a point on the table. And if you move something left 3, that would mean you'd subtract 3 from this x value. And if you're going to move it down 4, you're going to subtract 4 from the y value. And that's where you get the negative 3, 3 from. Negative 3, negative 3. And if I do the same thing with the point 1, 2, here we go. 1, 2, 3 left, and down 4. 1, 2, 3, 4. The only thing that we have to remember is the shape of the graph and where the horizontal asymptote is. Now if you move a horizontal line left or right, you're not really going to see that you moved that line at all. It's kind of like you're moving it on top of itself. So moving a horizontal line left 3 isn't going to change it. Moving it down 4, yeah, you're going to see that. So I'm going to draw that in here. So it used to start at y equals 0. Down 4 would move it to negative 4. So I'm going to graph the line y equals negative 4 as my asymptote. Right there. And remember that this is an exponential. Ooh, and look at this value right here. Right, that's a growth. We're multiplying something by 2, so it should increase like this. And if you wanted to put more points on it, feel free to. I think that 2 is enough to get the idea. If you need more points to see the shape, though, then you need to graph more. and I think you have some practice to try right now.